We are to construct a grouped frequency distribution with the data values that are listed in the table. In order to do this, it might be a good idea to start by organizing them in a stem and leaf display. From the stem and leaf display, we can see that the maximum value is 29 and the minimum value is 0. In order to find the class width, we should subtract the minimum from the maximum and then divide by the number of classes. We are told in the problem that we should have 5 classes. So we'll divide this by 5. This will give us a value of 5.8. We are to round this to the next whole number, since our data values have whole number decimal place significance. So our width will be 6. We begin with the lowest class limit, 0, and we'll add the width repeatedly. It's important that we do this vertically. So in other words, we add down below for the lower limit of the next class. So 6 plus 6 will be 12, plus 6 will be 18, plus 6 will be 24, and now we have 5 lower class limits. In order to find the upper class limits, we'll subtract 1 from each of the lower class limits. 6 minus 1 is 5. 12 minus 1 is 11. Or we can just add the class width repeatedly like we did to find the lower class limits. 5 plus 6 is 11, plus 6 is 17, plus 6 is 23, plus 6 is 29. So now we have the class limits. The next thing that we might do is find the frequencies. The first class goes from 0 to 5. So looking at our stem and leaf display, we see that we have 6 values between 0 and 5. From 6 to 11, we have 1, 2 values. Between 12 and 17, we have 0. Between 18 and 23, we have 1 and 4 more, so 5. Between 24 and 29, we have 7 values. The midpoints we would find just by adding the class limits and then dividing by 2. So the first midpoint would be 2.5. After that, we can just add 6, or we can continue to do the same. 6 plus 11 would be 17, divided by 2 would be 8.5. And then 14.5, 20.5, and 26.5. For the relative frequency, we would divide each of the frequencies for each class by the total number of data values. There are 20 data values in this data set, so the relative frequency for the first class would be 6 divided by 20, which would be 0.3. 2 divided by 20 would be 0.1. 0 divided by 20 would be 0. 5 divided by 20 would be 0.25. And 7 divided by 20 would be 0.35. And this should all add to 1. Cumulative frequency is obtained by adding the class frequencies as we go from the lower limit of the first class to the upper limit of the last. In other words, in the first class, we would accumulate 6 data values. If we continue from the lower limit of the first class up to the upper limit of the second class, in other words, between 0 and 11, we would pick up 2 more for a total of 8. Then in the next class, we'd pick up no more, so that cumulative frequency is still 8. In the next class, we pick up 5 more for a total of 13. And in the next class, we pick up 7 more for a total of 20.